So now we're going to move on and do this by elimination. And most people tend to like elimination better. And all this entails is you want to add the equations together. The key thing being you need to have one of your coefficients so that when they add together you'll get 0. So notice in our case we have a positive 3y and a negative 3y. When we add these two equations together, we'll have 7x, 0y's here, and negative 7 plus 7 is also 0. Solving this for x, we'll get our x is 0. And now that we have our x value, we find our y the same way we did before by just substituting this into one of our two equations. So there's our answer. However, we still need to check. So it works in the first one. Trying into the second one. So it works. So here's our answer. Now notice our x coefficients are at least similar. They both have a 2, but we need them to be opposite of each other. So how we can take care of that is just multiply one of the equations by negative 1. So then our first equation is still going to stay the same. Our second equation, multiplying that negative 1 by everything. Now notice the x's have those opposite coefficients. So now when we add our two equations, those will go to 0. 1y plus 5y is 6y. 7 plus negative 3 is 4. When we divide both sides by 6, we can simplify and get 2/3. And then we'll go ahead and substitute this into one of the equations. Once again, it doesn't matter. I'm going to go with the first one. So we'll get our answer. But once again, let's check it before we circle. And 9 divided by 3 is 3. So it checks. So here's our answer. Now notice, none of our coefficients are the same. And so what we need to do is multiply one of the equations by a number, or both of the equations by a number, to get our coefficients to be the same number, one positive, one negative. So notice we could multiply the second equation by 2, and then we'll get our y's to match up. So our first equation will stay. Our second equation becomes 4x minus 2y equals negative 14. So remember that 2 gets distributed to everything. Now notice our y's are opposite, so we can add them. And we'll get x equals negative 2. Now we have to figure out our y. But once again, we've got to check our answer. It works, so that is our answer. Alright, once again, solve by elimination. We have fractions, but think back to chapter 1. We can eliminate our fractions. And we can do this by multiplying by what would be our common denominator. So in this case, our common denominator would be 6. And actually in this case, it would be 6 as well. And so now, our equations would be now at least these look a little easier. We don't have our fractions. However, we still don't have any coefficients that match up. So what we need to do is multiply both equations by a number to get our coefficients to even out. And it doesn't matter whether you want to work with the x's or the y's. I'm going to go ahead and work with the x's. And notice we can get our x's to 24. So let's multiply this by 3, and this one by a negative 8. And we'll get 24x plus 9y. So we'll have our two equations. Now notice our x's here are opposites, so we can go ahead and just add our equations. So our x's go away. So we'll get y is 2. And we still have to get our x. And so I'm going to go ahead and plug this in for y. Remember though, we do need to check our work. Answer. Alright, now, once again, we're going to solve the system with elimination or substitution. Notice it doesn't tell us which way to use it. Notice, though, we already have variables by themselves. So substitution is going to be your best bet. And it doesn't matter which one you substitute into the other. So I'm going to go ahead and just substitute this one in for the y in the first equation. We'll get 0 equals negative 15 halves. Well, 0 doesn't equal negative 15 halves. So what this tells us is there is no solution. So this means the lines don't intersect anywhere. So first things first with elimination, we need to get our equations to line up. So let's subtract over this 4y. And now, if we multiply this second equation by negative 2, we'll be able to get our x's to cancel out. So we'll have 8x minus 4y equals 10. And then negative 8x plus 4y equals negative 10. When we add them together, we'll get 0 equals 0. So this means we have infinitely many solutions. So, once again, we want it so that we've got x comma something. So let's go ahead and solve the second one for y, so that we have y equals something with an x. So we'll have negative 2y equals negative 4x plus 5. Divide everything by negative 2. We could also write an answer so that it's something comma y, and then as long as this only has a y in it. And since this first one's already close, because we'd have to get x by itself, we could divide both sides by 8. You get x equals 1/2 y plus 10 over 8 reduces to 5/4. And so then we have 1/2 y plus 5/4. Either one matters. Typically, people go with the x, so typically this is what you'll see as an answer, but they both are correct. Alright, so now solving three systems with three variables by elimination. So once again, I'm going to color code and try to keep top blue, green, and red. So once again, we've got to get two together to eliminate a variable. So let's just go with the first two. So if we do x plus y plus z equals 4, and the second one, notice if we go ahead and add these up, we get 3x plus 2y equals 5. Notice we're down to two variables. So once again, now we got to pick two other equations and get the z to cancel out. So if we go with the second two, so this one and the bottom one, notice we don't even have to multiply by anything. When we go ahead and add these together, now notice both of those have an x and a y. So now we can combine these and use our elimination. So if we notice our y's will cancel out, so we don't need to multiply by anything. But once again, we only have one variable. We need to substitute that back in to get our second variable. So let's just go ahead and substitute it in to here, and it doesn't matter which one we pick. Subtract 4 from both sides, so y is going to equal 1. And now, once again, it doesn't matter, but we've got to go back to the beginning and pick one. The easiest one's probably this top one over here. So let's go ahead and use this. So we have x, which is 1, plus y, which is 1, plus our z we don't know, equals 4. So 2 plus z equals 4. Z is 2. So our solution, once again, we've got x, y, z, so 1, 1, 2.